Hello everyone. Today we'll be looking into a chemical engineering question from GATE 2021, question number 49. The following isothermal autocatalytic reaction A plus B gives 2B with the reaction rate minus Ra is equal to 0.1 CaCb in mole per liter per second is carried out in an ideal continuous stir tank reactor or CSTR operating at a steady state. Pure A at 1 mole per liter is fed and 90% of A is converted in the CSTR. The space-time of CSTR is dash seconds. So this is a question from autocatalytic reactions and ideal reactors in chemical reaction engineering, and the reference NPTEL series can be found in module 1 lecture 30 recycle reactors, autocatalytic reactions, chemical reaction engineering 1, homogeneous reactors by Professor K. Krishnaya, Department of Chemical Engineering, IIT Madras. So let us write down the given information here. So we have a CSTR with the space time as tau. The inlet of CSTR has Ca0 as 1 and Cb0 as 0 because the feed is pure A. And the outlet will have Ca and Cb as the outlet concentrations of A and B. And it is given that the reaction is an autocatalytic reaction, A plus B giving 2B. And the rate of the reaction is given as minus Ra is equal to 0.1 CaCb. For a CSTR, we can write the design equation as tau is equal to Ca0 minus Ca by minus Ra, where tau is the spacetime of the CSTR, Ca0 is the initial concentration of the feed, and Ca is the final concentration, and minus Ra is the reaction rate. So here the feed is pure A, so Ca0 is given as 1 and Cb0 will be 0. So given that the conversion of A is 90%, so that means Xa is equal to 0.9. So from this we can calculate Ca as Ca is equal to Ca0 into 1 minus Xa, and that will be 1 into 1 minus 0.9, and that will be equal to 0.1. So tau is equal to Ca0 by C minus Ca by minus Ra will be Ca0 minus Ca by 0.1 CaCb. So here we have the value for Ca0. We just found the value for Ca from Ca is equal to Ca0 into 1 minus Xa, which came to be 0.1, but we don't have the value for Cb. So to find the value for Cb, we can do the following. For autocatalytic reactions, the total concentration in the system will always be constant at any given time. So that means Ca0 plus Cb0 at initial time will be equal to Ca plus Cb, and that will be equal to C, which is an arbitrary composition value. So this equation Ca0 plus Cb0 is equal to Ca plus Cb will hold true at all times. So we have the value for Ca0. We know that Cb0 is 0. We found out the value for Ca from Ca is equal to Ca0 into 1 minus Xa. So we can find the value of Cb here. So just substitute the values. 1 plus 0 is equal to 0.1 plus Cb. So Cb will be 1 minus 0.1, and that is 0.1. Now we have all the values required for the design equation. Substitute all the values in the equation. Tau is equal to Ca0 minus Ca by 0.1 CaCb. Now We just have to substitute all the values here and we can find tau. So tau will be 0.9 by 0.01 into 0.9 and that will be equal to 100 seconds. Thank you.